first part of the problem along that straight ramp. We need to draw the object of interest at the start of the problem and at the end of that section. The motion diagram for the rocket will show that it's accelerating up the ramp. And we know that acceleration is 1.25 meters per second squared. Because the acceleration is up the ramp, we need to be careful and make sure that we choose our coordinates that way. So I'm going to choose my positive x direction to be up that direction. So then we can say that the rocket at time t equals 0 is at x equals 0, and it has an initial speed of 0 because we're told the rocket starts at rest. At this later time, we don't know what it is. We do know that the rocket has moved 200 meters up the ramp. We do not know the velocity at that point. Now we do know a lot of information. Starting position, starting speed, the final position, and the acceleration. And if we're thinking about this problem and finding out where the sled is going to go in the long run, we know that we need to know this speed at this point because that will provide the launching speed for the rest of the problem. So let's find out that speed. We know our starting position. We know the final position. We know the initial velocity, the acceleration. And we try to find the final velocity. The only thing that's missing from there is time. We don't care about time. We don't know the time. So we're going to use our fourth kinematic equation to solve for that velocity. Reading off the picture, we know the starting velocity, the final velocity is what we're looking for. The initial velocity was 0. The acceleration is 1.25 meters per second squared. And the final position is 200, and the starting position was 0. So we know that the velocity is the square root of 500. So we know the final speed is 22.4 meters per second. That's the speed that the rocket sled has when it continues off into the air for the projectile part of the problem.